Let's talk about how to calculate the shortest distance between a point and a line. Just think about it for a second. What do you think the shortest distance would be? How do you figure it out? Like, imagine whatever room you're sitting in right now. Pick a wall around you. What's the shortest distance to get from where you are in the room to that wall? Well, you would have to draw a line that is perpendicular from yourself to the wall. The line that you walk along would be perpendicular to the wall. Now, we'll be doing this in the coordinate plane today, so as you might imagine, we should review the distance formula first, because in order to calculate the distances in the coordinate plane, we use the distance formula. So remember that to use the distance formula, which is right up here, you need to know the coordinates of each of your points. Point A is at the point -3, +7, and B is the point 2, -8. And I'm labeling these as x1 and y1 and x2 and y2 so that I can fill them into my formula. Remember that x is always the first term, y is always the second term of a coordinate pair. And I'm just putting ones as subscripts. Those are basically just labels saying this corresponds to the first point and this corresponds to the second point. So I'll just take each of these 4 numbers and plug them in the corresponding parts of my formula. So the distance from A to B, which I'll call AB, is giant square root, parentheses, x2, which is 2, minus, because that's what the formula says, and then x1, which is -3. Now, I wrote that as a minus so that you could see where all the signs and everything are coming from, but I highly recommend that you write that as a plus instead, because subtracting a negative number is the same thing as addition. Then I closed my parentheses and I squared it, because that's what the formula says. Then I wrote a plus sign and opened a parentheses, because that's what the formula says. And then y2, which is -8, minus, because that's what the formula says, y1, which is 7. Close your parentheses and square it. Now you can plug this entire thing straight into the calculator if you wish, or you can solve it step by step. 2 + 3 is 5, -8 minus 7 is -15. The square of 5 is 25, the square of -15 is +225, so I get the square root of 250. As a radical, if you're asked for an exact answer, that would be 5√10. Remember back to your Algebra 1 radical skills for a little bit. Or if you would prefer to use a decimal approximation, it would be approximately 15.8 units away. We'll be using the distance formula to calculate all of our distances today, but let's again talk in general about how do you get from a point to a line in the shortest distance possible. Would it be this distance? Would it be this distance? Or this distance? Should I go from my point to the origin? Should I go from my point perpendicular to the line? Or should I go from my points straight down, or straight to the right, or to the left? Which one is actually going to reliably get me the shortest distance? Is it PQ, PR, or PS? Well, because I already told you the answer, you should know that the answer is the one that's perpendicular, which would be PR. And it's not just because I said so, you can actually prove it to yourself. If you look at PR as one of the legs of a right triangle, both PQ and PS would be a hypotenuse of the right triangle. So looking at this right triangle right here, PR has to be shorter than PQ, because PQ would be the hypotenuse, and the hypotenuse is always longer than each of the legs. And same idea with PS, it would be a hypotenuse, so that has to be a longer side than PR. PR is the absolute shortest distance from point P to line M, because those two lines are perpendicular. So in general, this is what you'll do to solve each of these problems. Step number 1, you have to figure out what is the slope of the line that you were given, because the direction in which you will travel to get from the point to that line needs to be perpendicular. In other words, it has to have the opposite reciprocal slope. Once you know what that slope is, use it to count towards the line until you intersect it. Whatever the point of intersection is tells you one of the points that you'll use in the distance formula. The other point, of course, is the original point that you were given. So once you know the original point and the point of intersection between the perpendicular line and the given line, plug those 2 points into the distance formula and get your answer. Let me show you what I mean. Here's line L and point A. And I want us to calculate what is the shortest distance to get from point A to line L. First thing we need to know is the slope of line L. I go up 3 and right 4. So the slope of line L is 3/4. Now to get from point A to line L, I would need to count in a perpendicular direction. In other words, the opposite reciprocal of 3/4, which would be -4/3. So from point A, I'm going to use my slope to count towards the line. Now, you might think, okay, well, this is -4/3, so I go down 4 and right 3. And I mean, that's correct, but it's going in the wrong direction. So instead of going down and right, let's go up and left. So up, 1, 2, 3, 4, that's a positive movement. And then to the left, 1, 2, 3, that's my negative movement. And I intersect right here. So I'm going to go up 4 and right 3, as displayed by this dotted line, and until I reach line L, and I'll intersect at point P. Point P happens to be the point 3, 2. Okay, cool. So now I know my coordinates, and I'm going to plug those into the distance formula. A was the point 6, -2. P we figured out was the point 3, 2. So I'll just plug it all into the distance formula, crunch those numbers, and you get an answer of 5 units. All right, let's try another example, make sure we understand what's going on. I've got point B, and I've got line M. And in order to get from point B to line M in the shortest distance possible, I need to move in a perpendicular direction. In other words, I need to know what the slope of line M is so that I can find its opposite reciprocal. Thankfully, it's pretty easy to identify slopes for lines that have been graphed in the coordinate plane because you can just count. So I'll go down 3, 1, 2, 3, and right 2, 1, 2. So that is a slope of -3 over +2. The perpendicular slope for -3/2 would be +2/3. So from point B, I'm going to go up 2, 1, 2, and to the right 3, 1, 2, 3. And I'll just keep doing that until I intersect line M. So up 2, 1, 2, 1, 2, 3 to the right, up 2, 1, 2, 3 to the right. So it looks like I intersect at this point right here when I travel along this perpendicular line from B to point P. So P we have found is the point 5, -2, and B was the point -4, -8. So I'll take those numbers and plug them into the distance formula to get the length of BP. As an exact unit, it would be 3√13. As an approximation, it would be approximately 10.8. So the first two examples that we've done have been a little bit easier because they intersected at an identifiable point on the given line. That will not always be the case. Let me show you an example. Here we have point C and line N. The slope of line N is 1/4, which means I need to travel from point C to line N in a direction of -4 for my slope, because -4 is the opposite reciprocal of 1/4. So from C, I'll go down 1, 2, 3, 4, and right 1. Down 1, 2, 3, 4. Okay, well, I'm not really sure entirely where in this region it crosses. I just know it's around here somewhere. But somewhere isn't quite good enough, and estimating is not exact enough. I need to know exactly what that point of intersection is so that I can calculate the exact distance. Well, how am I going to do that? How do I know where point P is? We're going to set up a system of equations in order to solve this. We're going to write an equation for line N, which should be pretty easy because it's already been graphed for us. And we're also going to write an equation for line CP, which might be a little bit more challenging. So let's take this one step at a time. First, we're going to write the equation for line N. We'll write it in y equals mx plus b form, because that's the easiest to identify. The slope is 1/4, we had already talked about that earlier. So that's m in y equals mx plus b. B is the y-intercept, so where does the blue line hit the y-axis? It hits right here at -2. So B is -2. So the equation for line N is y equals 1/4 x minus 2. Well, that was pretty easy. Now let's write another equation, one that represents line CP. What we know about CP is that it passes through point C, which we can easily identify as the point -4, +5. And we know it has to have a slope of -4 because that was the opposite reciprocal of 1/4. Now we're going to need our equation to be in slope-intercept form, y equals mx plus b, and in order to get there, we'll have to start with point-slope form, y minus y1 equals m times x minus x1. So the point that we were given, point C, -4, +5, that's the x1 and the y1 that I'll plug into my formula, and m is -4. So when I plug in my values, I get y minus 5 equals -4 times the quantity x minus -4, which again, a better way to write that is x plus 4. Then I'll distribute, and then I'll add. So the equation for line CP is y equals negative 4x minus 11. Always do a quick sanity check to make sure that that seems reasonable. Does it seem like if I were to continue this line, it might cross down here at negative 11? Yeah, that seems pretty reasonable. So this looks like a pretty good equation to model the information that I have. So these are the two equations that we've written. Y equals 1/4 x minus 2 is the equation for line n, and y equals negative 4x minus 11 is the equation for CP. What we're interested in is where do they intersect? In other words, when are they equal to each other? So I'm just going to get rid of my y since they're both y. If y equals this stuff and y equals this stuff, then all of this stuff must be equal. So I could write this equation, 1/4 x minus 2 is equal to negative 4x minus 11. Now, I don't know about you, but I don't really care too much for working with fractions. I'd rather get rid of it. So pro tip, multiply everything by the denominator, and that causes the fraction to cancel out. So I'm just going to multiply everything in this equation by 4 and make it all nice pretty integers. So 1/4 times 4 is 1, negative 2 times 4 is negative 8, negative 4 times 4 is negative 16, and negative 11 times 4 is negative 44. You don't have to do it this way. If you don't mind working with fractions, then be my guest, work with fractions. Whichever way you decide to solve, you should eventually end up with a fairly ugly answer, and that should be expected, right? We didn't know where P crossed line N. We knew it was going to be ugly, so it's not surprising that we got such an ugly answer. It is good to do another sanity check and make sure that that x value seems reasonable. I got negative 2.1 approximately, so if I go negative 1, 2, and a little bit further, yeah, that seems like a pretty reasonable x value for P. But what's the y value? In order to figure that out, we'll have to plug negative 2.1 and stuff back into either of the original equations. It doesn't matter which of the original equations you plug it back into, you should get the same y value regardless. I'd prefer to work with the one without fractions though, so I'm going to plug in my negative 2.1 yada yada yada, keep all of those digits in your calculator, multiply that by the negative 4, and then subtract 11 from it, and I get a y value of about negative 2.5. Okay, so now we finally know that the point of intersection between CP and line N is point P, negative 2.1, negative 2.5. So I'll take the coordinates for P and the coordinates for my original point C and plug them into the distance formula, and I get approximately 7.7 units. I'd like you to try this last example on your own. I've taught you everything you need to know in order to solve this problem, so pause the video and give it a try. Alright, let's see how you did. Our goal is to calculate the shortest distance from point D, which is negative 5, negative 2, to line P. Line P has a slope of negative 2/5 because I go down 2 and right 5. So that means that to get from D to P, I would need to use the opposite reciprocal slope, which would be 5/2. So I'm going to count up 1, 2, 3, 4, 5, and to the right 2. But that's kind of unclear exactly where did that line cross. It's somewhere around here, point P. But the problem is we don't know exactly where P is. So to figure it out, we're going to have to write an equation. First, we'll start by writing an equation for line lowercase p. We do have two different p's in this problem. Keep track of your uppercase versus lowercase. Lowercase p is the line, uppercase p is the point. The equation for line P would be down 2 and right 5 for the slope. We already knew that. And our intercept is 1. So if B is 1 and M is negative 2/5, then the equation of line P is y equals negative 2/5 x plus 1. Alright, now I need to know the equation of line DP. In order to do that, we'll use point-slope formula. D is the point negative 5, negative 2, and the slope of this line is positive 5/2. So I'm just going to plug all of those numbers into their appropriate places in this formula. Do a little simplifying because I don't like this minus minus stuff. I'll make it a plus. Then I'll distribute. And I mean, it gets kind of ugly, but this is the equation of line DP. Now that I know the equations of both lines, I can figure out where they intersect by setting them equal to each other. So I have negative 2/5 x plus 1 is equal to 5/2 x plus 21/2. Again, I don't really like dealing with fractions if I don't have to, so I'd rather multiply by the least common multiple of the denominators. We can't just multiply by one denominator to get rid of everything this time because we have two different denominators. So I'll just multiply by the least common multiple, which is 10. So if I multiply negative 2/5 by 10, I get negative 4. If I multiply 1 by 10, I obviously get 10. 5/2 times 10 is 25. And 21/2 times 10 is 105. This equation feels way easier to work with than this one. So now I'll just solve, solve, solve. And again, we get a really ugly answer, which is to be expected. That's why we're having to do this extra work, is because we could not identify exactly where p was. But it does seem reasonable to have approximately negative 3.3, because 1, 2, 3, and then a little bit further to the left, that's approximately where the x value of p is. So we're looking good so far. But we also need to know the y value of p. To figure that out, I'm going to take negative 3.3 and plug it back into either of the original equations. It doesn't matter which of the equations you plug it back into. I'm going to plug it into the first one because it has less fractions. And we get approximately 2.3 for our y value. Which again, that seems pretty reasonable because I count up 1, 2, and a little bit further, and that's about where the y value of p is. So now that I know the coordinates of point P, and I know the original coordinates of point D as well, I'll just plug all 4 numbers into the distance formula, and I'll get my answer. So you should end up with approximately 4.6 units for your final answer. And that's all you need to know about calculating the shortest distance between a point and a line. In our next video, we'll be talking about how to calculate the shortest distance between 2 parallel lines.